Alrighty, so we've covered all of factorization, and algebraic fractions really does play hand in hand with factorization. Mainly because, and you guys know this from year 10, but if we want to simplify algebraic fractions, more often than not, you're really going to need to make use of the fact that you can factorize things very, very well. If you can't factorize things very, very well, you're going to find this topic quite hard. So I would then go back, make sure you're really good at factorization, and then come back to algebraic fractions, okay? So to start ourselves off, we're going to do the very, very basics all the way from year 7 all the way to year 10. Okay, so we're going to start with the basics and work our way up just because I want to make sure everyone can do it. So the first thing we're going to look at is adding and subtracting fractions. So just a quick reminder, guys, when you add and subtract fractions, it's really important for the denominator to be the same. I know people say this to you very often, but I want to make sure you understand why, just so you can get a visual as to why this is so important. If I have a pizza and I cut it into, let's just say, 8 slices, and I say to you, hey, in the morning I ate 2 slices of pizza, and then in the afternoon I ate 3 of them. So in the morning I ate 2 slices of pizza, and in the afternoon I ate 3 more of those slices. If I was to ask you, with this picture example, how many total slices do I eat? It's pretty obvious that all you really need to do is, all you need to really do is take this fraction, lay them on top of each other, and boom, that's how many slices I ate. Everyone see that? So I ate 5 altogether. Pretty obvious, right? So I've had a couple students in the past ask me, well, why does the denominator stay the same? Why are we not adding the denominator? I hope this makes it very clear, right? We're not adding the denominator because the denominator is not changing. The number of slices in total that we have does not change. It's just the number of slices that you're adding that changes, so that's the numerator, okay? Now, the problem arises, I hope you understand, when if I was to say, okay, I ate 2 slices of this pizza, and then I ate 3 slices, or let's say I ate 2 slices of this pizza. Also diabolical to cut a pizza like that, but hopefully you never see something that terrible in your lifetime. But if we talk about this pizza instead, and I say, okay, well, I ate 2 slices of that pizza and 2 slices of this pizza, when we try and apply the same method, so when I try and duplicate this and then duplicate this and lay them over each other, you see we end up with a bit of a problem. Well, how many slices did I eat? I don't really know. You know what I mean? So, mind you, the whole is still the same, so I'll try and lay this one over a bit more neatly. I'll just make it a little bigger so that it lays over nicely. The whole is still the same. 1 whole is still equal to 1 whole, so it's still a whole pizza. But because you cut it into different slices, I don't really know what to tell you. How much is that little extra part, and how much is this part that we've undercounted for? I don't really know how to tell you how much of the pizza I ate anymore, because I'm not talking about the same pizza, if that makes sense, okay? So I hope this gives you a little bit of an understanding as to why it is really, really important for us to have same denominator. And I'll just write that down here just so that you guys have it in the notes so you know what I'm talking about. So that just gives you a little bit of an idea. Let's go to a very simple example, and then we're going to move to more year 11 style questions, okay? So starting with a very basic example, I want you guys to start with this question. A reminder that you are allowed to multiply this by 10 on 10 for no particular reason. Can someone, before we start this question, just remind me why I'm allowed to do that? Why can I just randomly take a fraction and multiply the numerator and denominator by whatever number I want? Not saying that you should multiply it by 10 on 10, but just saying that I am allowed to. Why am I mathematically allowed to? Why does it not change the value of anything? Okay, why does doing the same thing to the top and bottom mean I'm not changing the value? Because it looks like I'm changing it. Kind of. I'll give you a hint. What is 10 on 10? 1. So I'm multiplying the fraction by 1. Does that change anything? No. So visually it does change it. It would make it 20x on 30. But in terms of what it represents out of a whole, it's still the same amount. Okay? So go ahead and try this question. I think you guys know how to do this, but we'll go through it together anyway once you're done. So going through this question, pretty much all you have to do is you multiply this by 4 on 4, and you multiply this by 3 on 3. Sometimes it's called cross-multiplying. I just like to think of it as, well, I know that I want this fraction to have the same denominator as this fraction, so if I multiply them by each other, I'm obviously going to have the same number. Pretty standard approach, okay? So my left fraction on the numerator becomes 9x, and my bottom fraction on the denominator my left fraction on the denominator becomes 12. And then the right one becomes 8x, and the bottom becomes 12. So then I just have 9x minus 8x, and that gives me x on 12. And that's my fully simplified form, okay? So now we're going to go into very similar questions, still going to stick to addition and subtraction, but we're going to do some slightly harder examples, okay? Alrighty, so my hint for this whole topic, the algebraic fractions topic, is going to be make sure that if there is something you can factorize, you start by factorizing it. So do you guys notice that in this question originally, there was nothing for me to factorize? So I just started making a common denominator. In this next question I'm going to give you, there is something for you guys to factorize. I want you to really look out for it and make sure you get into the habit. Any question you get on algebraic factorization, you're going to first check if you can factorize, then try and make a common denominator, okay? So go through this question, and if you're struggling with it, it's all good. We're going to go through it once you guys are all done giving it a go. I do want you to try and get as far as you can on your own, though. And then if you get stuck, we'll go through it. So to do this question, we're going to start off by factorizing, as I said. So the first thing I'm going to do is, the only thing I can really factorize is this, with highest common factor being x, so I can pull the x out and I get x minus 1. Then I see that we do have a common factor on both denominators of x minus 1, so the only thing I'm really missing is an x on this one. So I'm just going to multiply it by x on x. So it simplifies to give me 2 plus x, x minus 1, minus 5x, x minus 1. And then I end up with 2 plus x, so plus 1 minus 5 is minus 4x, all over x minus 1. And then I do see that I can factorize the numerator, so I can pull a 2 out. But you don't necessarily have to do that. I always like to factorize at the end if I can, because in case there is something I can cross out. But in this case, there wasn't. So it's good to just leave it in factorized form. But if you didn't leave this specific question in factorized form, that's okay. You'd still get full marks if you stopped right here. But it's a good measure just to always factorize in case there's something you're missing, like there's 2 brackets that you could perhaps cross out if you factorize. Okay? So the next question is going to have another little trick in it. And this one has a very common mistake that I see almost every single student making when they start this topic. So I'm going to put this question on the board. Hopefully nobody makes the mistake because I have shown it before, but I want to show it again just to really lock in that this is a very common mistake that people make. Okay? So here's the question. I'm not going to tell you guys what the common mistake is just yet, but I want you to give it a go and then we'll go through it and I will point out what the common mistake is. So going through this question, seems pretty simple on the surface, so I'm going to just multiply the right by 4 on 4, multiply the left by 5 on 5, and I end up with 10x plus 5 all over 20 minus 8x minus 12 all over 20. Now, So all I did in that step was just expanded the 4 into the numerator and expanded the 5 into the numerator. And now, this is the part where I see lots of mistakes happen. And it's with this negative right here. People forget that this negative is applied to the entire fraction. So it's almost like this fraction is in an invisible set of brackets. They don't actually write the brackets down though, because it's a mathematical notation that whoever the mathematician is that is doing the question should know that that negative is applied to the brackets, okay? So we kind of know the negative is applied there, and so you need to expand it into the numerator of the fraction. So you end up with 10x plus 5 minus 8x plus 12, and that's the one that really is a killer. A lot of students do it. Chris, it seems like you did it. You threw your head, you're like, damn it, I made the common mistake. All right? So it is a killer. It happens so often, and I can't stress, like, almost every single year that I teach, I see this mistake happen to at least one student, if not sometimes the whole class, until I tell them about it and they're like, yeah, okay. All right? So just a good thing to keep in mind. Now, it's all over 20, and then we end up with 10x minus 8x, which is 2x, and then 5 plus 12, which is 17. Am I right about that? I am. Okay. All over 20. Everyone cool with this? Beautiful. So these are generally as hard as it gets with addition and subtraction problems. Don't get me wrong, it can get a little bit harder, but you guys will see that in your exam practice anyway. Okay? So now I would like to move on to multiplication and division, and we will stop there. For today, we'll just do multiplication, and then next week we'll continue on with division. So with multiplication of fractions, these questions can get extremely messy if you don't factorize. I cannot stress enough, if you do not factorize, these questions are going to get out of hand extremely quickly, and they're going to look very scary to you. So let's look at a way that we can do these questions without really causing a fuss and also creating really complicated working out. So just to kind of relay what I mean, in my first year 11 exam, I remember doing algebraic fractions was in my first exam. And I remember for one question, mind you, I did extension math, so advanced math was supposed to be really easy for me. I walked into this exam thinking it was going to be a piece of cake, and for some reason, I just forgot to factorize things. And so in advanced math, what they do is they give you only like a certain amount of space to answer the question. So like say that this is the question, they give you space to answer the question, and you have to, like, your answer has to fit within that space. And they usually give you a relative amount of space to how hard the question is, right? So there was this one question I did, and it was supposed to be easy because the amount of space was quite small. And I ended up writing over 3 pages because I couldn't figure it out. Turns out it was just a multiplication algebra, like algebraic fractions multiplication questions, and I expanded everything. What was I thinking, right? So the question became so hard, and I still remember how I felt in the exam. I was like, oh my gosh, this is so hard. I can't do this. And then when I got it back and I realized what I did, I was like, are you kidding me? So take it as a lesson from me. Don't ever expand in these questions. It becomes disgusting to deal with. Not that you can't get the right answer by expanding. You can. If your algebra is good enough and you don't make any silly mistakes with negatives, you can get the right answer. But it's just going to be a nightmare, okay? So I'm going to just quickly put a question on the board. We'll do an example together, and then we'll revisit this next week and really do more examples and lock it in with also some examples of division as well. Give that one a go, and we'll go through it. And I'm going to do it the expanding way, just to show you guys why you should not. So you can see I've put down the method of expanding, and in this case it wasn't actually that bad, okay? So in this case the expanding wasn't too bad, but I also want you guys to know that this is a pretty chill question. I will show you guys next week a type of question that is really bad if you try and expand, but for now that's the expanding method. let's do the factorizing method. So I know I can factorize 3 out of the top, and then out of the denominator, there's nothing I can factorize. Then out of the denominator here, I can do x plus 1, x minus 1. That's why I said at the start of the lesson, it is really important that you guys are really strong with your factorization, just so you can write it down like this, okay? It's really important. And then finally, I see here, I can cross this x with this x, and then I can cross this x plus 1 with this x plus 1, and so my final answer is just 3x all over 2x minus 1. You can see, first of all, a lot less working out, a lot quicker, and second of all, what you notice is if I try taking the expanding route, so what I did is I expanded this and then expanded this, and I hope you guys know there's nothing, it's not algebraically wrong. I'm not saying it's wrong thing to do. You can do it. It's mathematically correct. You're allowed to do that. But I just want to show you that in terms of working out, it's really hefty, and then look what I had to do anyway. Factorize, okay? When you expand, you end up having to factorize anyway so that you can simplify it fully. So why not just skip the expanding step, because it's just an extra unnecessary step, and just factorize everything? Because we know if we have terms that are factorized, we can just kind of glue them all together and be like, yep, they're multiplied. Good. You don't have to expand them, okay? Unless obviously the question's asking you to. So I will stop there for today. And next week we'll come back and we'll continue with some harder multiplication questions, and then I'll also show you guys how to do division as well. Okay?